Coming up on this episode of the IoT Inc. Business Show.
We refer to it as a process because it's something that one of the great ways I've seen people draw a picture of this is really to make a circular picture, because security development lifecycle is not something that you ever finish unless you end of life your product and say we're not making that anymore. You just keep going around in this circle. So you do the first activity, you go all the way around the circle, and then you do the first activity again. You know, it's just a continuous security improvement process.
We all know, whether from experience or just intuitively, that bolting security on an IoT product after much of the development work has been completed, it's a total rookie mistake and a recipe for disaster. Yet it still happens. It happens by crowdfunding startups who don't mention security in their videos, all the way to internal teams in large organizations who emphasize the bling in order to get their projects greenlit. In this episode of the IoT Business Show, I speak with Chris Romeo about the Security Development Lifecycle, the polar opposite of the bolt-on that's been successfully used in IT security for years.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Chris Romeo. Chris is Chief Executive Officer at Security Journey, where he's made it his mission to change the security culture of organizations big and small. He has over 20 years of experience in security, including the areas of application security, penetration testing, and incident response. Chris is a listener of the podcast, and after reading his thoughtful note to me on security, I thought it'd be great to have him on the show. Chris, welcome to the show.
Thanks, Bruce. I'm glad to be here today.
So, Chris, what have you been working on this week?
So this week I'm actually working on creating some content that teaches people foundational lessons about security. And I think that has an interesting tie-in from an IoT perspective as well.
What do you mean?
So that's one of the big things that I see that's missing in the world of IoT is that developers, testers, those that are building the products and the systems that make up IoT, they're missing that foundational layer about security. They just don't understand what are the pieces that they need to put into the things they build.
So this is pretty early on, you're saying?
Yeah, I think the IoT market space is pretty early from a security perspective, meaning that the investments just haven't been made. And I think a lot of times it comes down to the overall awareness. You know, companies are so focused on getting products out the door quickly. Yeah. They're not dealing with the consequences, and there will be consequences to come in the future.
So how would you compare it to IT security?
So IT security has been a thing. It's been a series of processes and technologies and tools for, going on 30 years now.
Yeah.
So it's very mature. We've learned a lot, and we're not perfect, and we still got a lot of work to do from the IT security side. But I see IoT security as being in that year one place, and one of the challenges I see right now is that the folks that are doing IoT products, they haven't learned from the lessons that all the knocks we took in the last 20 years figuring this security thing out. They don't have that perspective because no one's exposed them to it.
Yeah, and another challenge, I don't know if you've seen this, but I've certainly seen it with my clients and just listening to folks in the audience, is no one really wants to pay for it either. They're, in terms of the customer. So the customer isn't necessarily asking for security yet. And so the product manager who's looking at all the features that they can potentially put into the product, they're saying, well, I don't know, it's not really being asked for. So how do you well, first of all, have you seen that conundrum, and how do you get past it?
Yeah, I have seen in my travels lots of different product managers that say, well, we just don't have a demand for security from our customers. Yeah. And I think if that's the conclusion they're drawing, I don't think they're talking to the right people these days. Because
what do you mean,
people want their personal information to be secured. If it's used, if it's stored in the cloud, if it's attached to a mobile application or any of the other places it can exist in the world of IoT. If you ask somebody outright, hey, how important is your information to you? Nobody's going to say, I don't care about that. You can put my social security number on the front, on your website if you want. No, so I don't think that I don't think that the customer perspective is truly being provided to those product managers there, and I think they need to really learn a lesson about this threat landscape that exists in the world of IoT.
Yeah, and I think that brings us into risk, and I think that's correct. I mean, I think the more sophisticated product managers are not just going to look at the rewards, but they're also going to look at the risk and then try to balance the two out. And what you're discussing really is the risks for not doing it. And the other point is sometimes customers just don't know what they really need, right? And I don't like to say that because it's almost blasphemous to talk about it in that way. But certain things like security, it's got to be in there from the foundation. So, why don't we start? Tell us a little bit about your background, and in particular your background in IoT.
Okay, so I spent the last 20 years being focused on the field of security. And I've had the opportunity to work in many different jobs, security engineering to incident response to application security to penetration testing. So I've had a good exposure to all the different, sides of security. And I spent the last 10 years at Cisco Systems prior to founding Security Journey here. And during my time there, I was part of the central security team. And our focus was how do we build security in to all the products that Cisco sells? Right. And that's such a crucial thing for every organization to kind of have figured out. So during my time there, I had a chance to interact with the IoT groups within Cisco and consult on various issues that they were dealing with. And it really opened my eyes and really turned me into a security evangelist in the world of the IoT space, because I see the risk. And I think a lot more people now are seeing that risk, but we're not at the right level where we need to be. So, I spent some time for Cisco traveling around the world talking about, I did a talk called The State of the Hack is Everything. And what I was trying to do was just point out that, there are bigger security challenges found in this IoT thing. And we have to have a way, to procedurally and to think through these problems and how are we going to deal with them. And then the last thing from an IoT perspective, I had the opportunity to be a judge in the Cisco had this IoT Grand Challenge where they had all these startups send in proposals as a request for funding. And so I got a chance to look at around 150 different proposals from all kinds of different directions in IoT. And that really gave me a perspective. And that's one of the things that opened my eyes to the fact that people weren't focusing on security as much, because I saw all the things that they were doing, but there wasn't really much security in any of those.
Yeah, it's tough though, right? Having been in a startup, you're starting up your product, and you need to get those shiny, flashing bells and whistles in there, and putting in that time. Like, you really need to put in that time. And maybe it's not, and we'll talk about it today, and maybe it's not as difficult as maybe people perceive it to be, but to put in that time to have a very strong security foundation is a trade-off, right, for these bells and whistles. And what are they trying to do? They're trying to get your funding. They're trying, in your particular case, maybe they did it the wrong way, because maybe there should have been a little bit more focus on security. But you see, again, even from a startup point of view, it almost can't be it can't be their opening hand to a certain extent, right?
Yeah, I mean, startups, they have to figure out what's the minimum amount of security that we can apply and still stay in business. So I truly respect, folks that are in that place. And my encouragement for them is figure out what that minimum amount is that you can do to be successful. Obviously, you can't do what a gigantic technology company is going to do in their process, because you'll never ship. right? But there
Right,
are some
right.
things that you can do to really, that have the best return on investment for you.
I think that's a good point. I mean, and we've talked about this before in the show, but a startup, the risk to a startup, the maximum risk to a startup is it pretty much takes them out of business, right?
Yep.
But the risk to a large organization, which is kind of where you're going on this ROI business, is much greater. And so, yeah, it really is a balance, I think, like a lot of things.
I mean, think about the reputational nature as well, right? So a startup really doesn't have a lot of reputation to worry about, whereas a big technology company, one vulnerability can result in customer, the opinions that the customers have can erode with just a single vulnerability. We always say, in the big technology world, our job in the central security team is to ensure we don't end up on the front page of the New York Times or Wall Street Journal. Because if we're there and it's a security problem, it's going to be messy for everyone.
It's a dark cave.
Yep.
Well, why don't we, I know that you're a big proponent of the security development cycle. So I want to ask you to give us a high level, what is the security development cycle? What does it do in particular, and how does it apply to IoT?
So a secure development lifecycle is a process. Okay, this is a process that works together with your product methodology that you're going through to actually create your product. And what it does is it provides activities that are focused on security that you can do at the different points within your development process. Okay. Sometimes it's referred to as security in the software development lifecycle, because everybody that builds products that include software, you have a software development lifecycle. You may not even call it that, but you have a series of steps you go through where people do, they put their code, they check it into GitHub or whatever. Something pulls that code out and compiles it, and eventually it gets posted on your website for a customer to download or for an auto update or something. So a lot of companies are going to have that process already. The part that they're missing is they don't have the security, which is what the secure development lifecycle layers on top of the software development lifecycle.
Got it. So you're saying that at each step in the software development lifecycle, there is a security step or steps that should be taken. And so what the security development lifecycle process does, or framework, I'm not even sure how to describe it, it pretty much communicates what are those things that need to be done at each of those steps. Is that right?
Yeah, correct. And we refer to it as a process. So because it's something that, and one of the great ways I've seen people draw a picture of this is really to make a circular picture, because secure development lifecycle is not something that you ever finish. Unless you end of life your product and say we're not making that anymore. You just keep going around in this circle. So you do the first activity, you go all the way around the circle, and then you do the first activity again. It's just a continuous security improvement process.
So this is obviously something that's not bolted on. This is something that's baked in right from the beginning, right?
Yeah, so that's almost a soapbox issue for me, the build security in versus bolted on, because bolting security on means that you're going to do all the development, all the testing for the product, and then in the last minute before you ship, you're going to do what you call security.
Yeah. Now, would you refer to this as security by design, or is that something a little bit more focused?
Yeah, I think security by design is a little bit more focused. But building security in comes into how do we let's build it in right from the beginning. From the first time that we have that light bulb go on over our head and we start to think of this new product we're going to build, we want to ensure that we're considering security and measuring the trade-offs on the investments that we have to do as we make our way from the requirements phase all the way until we release something out to the customers.
All right. Well, I think then let's go through those different phases, starting with the requirements. Just take us through each one, and we'll sort of chat about them.
Yeah. So the first part of any secure development lifecycle is going to be your requirements. And the idea here, just like with standard product requirements, we want to have a written set of guidelines or features and things that have to be included within the product. So, for example, we may have a requirement that says anybody who wants access to our mobile app or our cloud service or something has to be authenticated. That means they have to provide a username and a password. They have to prove who they are. Then we may have another requirement that kind of works in tandem with that one that says that, user passwords have to be a minimum of 12 characters long and have these characteristics of, one special character, one capital letter, one number, all of those things. So the requirements come down to how do we pinpoint the features and functionality that we require. And from the SDL perspective, these are the security requirements.
Now you've mentioned a couple of these table stakes. What are some other table stakes that you consider that pretty much have to be right from the very beginning in the requirements?
So I think a requirement about encryption has to be.
Encryption.
You got to have encryption. You got to have authentication that we talked about. You need to have authorization requirements that are going to say, how are you going to do access control? How are you going to keep the difference between Bruce and Chris when they're both using the same web service and ensure that Bruce can't read Chris's data and Chris can't read Bruce's data, right? There's an access control, piece that goes within the authorization part of that. Then there's also a logging component that makes its way into requirements. We need to, if we're going to be able to react to a security problem in the future, we need some data that comes out of the product to tell us what we're going to do. And a good place for people that really want to get a high level perspective on what are the requirements that I should put into my IoT related product. So there's an organization called OWASP. This is the Open Web Application Security Project. It's a not-for-profit. Everything that they create that people do via projects is done open source, so it's wide open for anybody to use. But they created this OWASP Internet of Things top 10 vulnerabilities.
Yes.
And this is a great place to find requirements. If you take these 10 problems that they're listing, and you can take those and add them to a list of requirements that go into your product, you will be miles in front of anybody else that you're trying to build a product against.
You're loving life. Yeah, we actually had Daniel Miesler of OWASP on for a 2-part episode. So if anyone wants to get into a little bit deeper on this, and we'll put it in the show analysis notes. But that's a great resource, and it seems like it's almost. Are there any other comparable resources out there, Chris, to OWASP?
No, I haven't found anything that has the depth of technical content and just so many volunteers that are super passionate about security. Yeah. So you can see that in the things that they create. There's just nobody out there that can keep up with them right now.
Awesome, except for the bad guys.
Yeah, that's true.
Yeah. All right. So we started requirements. We're making sure we get those table stakes in there. We're taking a look at OWASP, make sure we haven't forgotten anything. What's next after that?
Our next phase that we're going to look at is what we call design or secure design. And so we have our requirements that say, here's what the product has to do. Now it's time to figure out, how is this thing actually going to work? What are the modules? What are the subsystems and things? And we want to start by doing that exercise on paper. And a lot of people like to jump in and start writing code, and they like to skip this whole design phase. Right. But there's 2 very important things that happen from the SDL perspective in the design phase. And the first is what we call our attack surface analysis. Okay. This is a fancy term for let's consider all of the interfaces in our product where data could come from an untrusted source. And by untrusted source, I'm talking about the internet mostly. So is there an interface? Maybe it's a web interface. Maybe it's something that's used for administration. But we have to go through and we have to do an analysis of all those interfaces, just so we know what they are, right? Sure. A lot of times people start developing and they couldn't even tell you what all the interfaces are. Oh, right. Yeah, we found this XML interface this API interface over here on the side that everybody forgot about. Well, that's a recipe for security disaster right there. Sure. If you don't have a perspective on that.
Now, when you say interfaces, I think I get what you're saying, but can it actually boil down to the literal interpretation of that? And you mentioned API, an application programming interface. Is it going to be where you are using the different APIs, or is it go beyond that?
It'll be where you're consuming those APIs from. That's what I define as the interface. Okay. So it could be API interface, it could be the user interface. These are all places. What we're trying to do is just capture what are all the places where somebody could try to actually launch an attack against us. Yeah,
right. And this is, I guess this takes us into the IoT question, because before in IT, we were talking about networking security, or maybe separately we were talking about cloud security. But in IoT, and you talked about the different subsystems, so I want you to maybe go a little bit further on that. But we have to consider app security. You've talked about that, cloud security, networking security, web security, even system security. So what's your approach? What's your approach in that sense?
Well, I think we are relatively lucky in that the network / system, and even moving into the cloud space now, the security in those layers it's pretty solid, because it's based on that 20-year lessons that we've learned. So in my experience, I see that those are not the things that keep me up at night. The things that what keeps me up at night is the application security side. How good is the code that was written here? Did the person that was writing this code understand how to do this fancy thing called input validation, where when you take input in from the outside, your program should really test it and make sure it's not going to some type of an attack before it lets it kind of move through. So from an application security perspective, that's where I think we need to spend the majority of our resources into the future, and continue to bolster, network, system, cloud security. But I think I just feel a lot better about those layers.
And what are your thoughts on basically? Well, when I say system security, I guess I'm talking about bringing together the different security frameworks where where I've heard there's been potentially mistakes that have been made where you've expected, let's say, some authentication to happen in one place. And so the dependencies between these different subsystems, it gets more complicated, right?
Yeah, definitely, and that's something that's actually a good segue into another piece of design security, because to help you solve that problem, the Security Development Lifecycle has this idea of threat modeling. And threat modeling is where we're going to look at a design, and on paper, we're going to try to figure out how are we going to break this thing? What would a bad guy do in these situations? And to your point about the individual subsystems, threat modeling gives us a way to draw a picture of the different subsystems and interdependencies that we have between them, and then start to pick it apart on paper and look and see, okay, what is the data? What are the assumptions we're making from subsystem A to subsystem B? We're assuming that subsystem A has done the authentication and we're never checking it in B? Well, that's a bad idea. So, that's a threat. The threat is that we're not checking the authentication, that the credentials or whatever, that they have a valid session or whatever, if they're talking to subsystem B directly. And that's but threat modeling will help you to see those things, because it causes you to have to draw a picture. And remember, there's no code at this point. If you're doing this, you're doing this according to how, now in reality, a lot of times people are threat modeling things that they've already written code for. But in the perfect world, this is something you're doing when you're looking at a design and not at a series of, lines of code.
Well, let's face it, in the real world, sometimes people don't even have their security design architecture on paper or anywhere else anyway. It's just sort of evolved as it's been coded.
Yeah, right? Maybe it's on a napkin that's, hung up on somebody's whiteboard or something in a cube if you're lucky. But, a lot of times that's a struggle, is that there is no, you're like, you go into a company and you say, hey, what, let's take a look at your architecture here for security. And they're like, like, here, let me draw you a picture on the whiteboard. There's 2 boxes,
Yeah. And I forget about all the parts that are inside there. So Chris, what you're bringing up is important. I mean, the attack surface analysis, the threat modeling, and just by the way, you're obviously talking about it from a technical point of view, but from a business point of view, when we get back into the risk analysis, we need this anyway, because we're going to be assigning liabilities to each, risk and liability to each of these areas. So this is something you should have anyway, right?
Yeah, definitely. The threat modeling really does play right back into that risk equation that you were talking about, and business people can look at that list of threats, and business people should be looking at that list of threats that the technical people provide, and they should be they have to make that trade-off. Security is always a trade-off, right? If I invest this much money, I can eliminate that threat. And if you're not willing to invest that much money, you're telling me you're going to accept the risk for that threat. But this is a tool that really helps that conversation.
Yeah, and then it takes us back to our requirements, and like you said, it's a trade-off. So you're trading off the different requirements, but they should be there explicit for everyone around the table to see in the first place. And I think beyond anything else, there's a lot of value in just that.
Yeah, I agree.
So beyond, okay, so we've looked at our requirements, we've started sketching things out on paper, figuring out our design, looking at it from different angles, seeing where the threats are coming from. What's next after that?
So now it's time to actually write some code. So
Finally.
yeah, finally the engineers are all cheering, yay!
They're like biting at the bit.
We get to write some code. No more talking and drawing pictures, But yeah, so it's time to take that design that we have on paper and turn it into, the actual code. And there's a few things that we want to consider from the SDL perspective. And the first is, how are we going to ensure that we follow good secure coding practices and principles?
Okay. And what does that mean?
So what that means is that there are certain things, like I mentioned, input validation already. Okay. We want our developers to be thinking about the fact that this input I just received through this interface, and it's coming into the code that I'm writing here, is coming from the internet. So I can have no trust for that level of code. I have to assume that has an attack in it, and I have to do the right things to ensure that I don't allow that code to ever be processed as a command or be passed through. It has to be cleaned and made sure that there's nothing bad that's existing within it.
Okay. And so continue on that thought then.
So it's good to have a document. And CERT is famous for their secure coding with C and secure coding with Java. They have these documents that people can use as a reference. Great place to start. And what it does is, it goes into the nitty gritty about, don't use these functions. If you're going to do, it just goes into all of that level of detail. So it's good to have that written down. In my experience, it's tougher to get the programmers to actually read those things and comply with them. So one thing you can do if you're using the C language, and I know a lot of folks that are doing embedded development are still using C as their language to do that. You can actually create your own what we call a safe C library. So the C programming language has a number of functions that are known to not check input correctly. Mm-hmm. And this is what's been causing the buffer overflow type of security vulnerabilities and exploits and things for the last 30 years of our life. All comes down to the fact that the C programming language, nobody ever added the code to, when you print something on the screen or when you take something in as input to verify that, it isn't too much data for the amount of space you have to store it in. So one of the things I've seen a lot of companies do is they create their own safe library, and what they do is they rewrite those functions and they create a secure version of it that does that boundary checking. And then what that secure version does is it calls the original, but they already know that the validation has been done. So that's a way to get past the challenges of those vulnerabilities.
Now, this sort of takes us, or does it? I'd like to talk about frameworks, but can you consider this a type of framework then?
Yeah, this is as close as you can get to a framework, right, for the C language, C doesn't have that same framework influence that web programming and Java programming does. But yeah, frameworks is a great example, especially when you're in the web and Java world, of a set of, what they do is they figure out, they'll provide you some authentication routines, for example. Nobody has to write authentication code anymore. Like if somebody's writing their own authentication code right now, they need to stop, find a framework and plug it in, because with all the work that's done, you can do your authentication through Google's service and through Facebook and all these other things. Don't create your own, reuse, and that's what the framework does for you. It provides you with features and functionality that are standard. They've been tested. A lot of people are looking at the code, and then you can call upon those, the calls within those frameworks to really save you a lot of time in the development process.
So let's get a little bit more explicit. A framework is going to be used. Is it strictly in the web? We talked about, I guess, as close as we can get in the programming environment, on the web, using Java, another programming language. Where else are frameworks used, and how do you explicitly use them? Is it just routines that you can incorporate into your code?
Yeah, primarily my experience with frameworks has been on the Java side in developing different applications. But yeah, it's like a library. It's a jar file that you can include that then provides you with a whole series of different calls that you can make. And, then that way you don't have to write your own authentication library. You can call on their authenticate function. And that authenticate function already has the concept of passwords and the, usernames and all of the things that go into having a secure implementation. That's already done in the framework for you. So you don't have to recreate, you don't have to write that code yourself.
So where else is it used? Is it used in encryption and authentication, authorization? Are these other areas that it's used for as well?
There's two different ones in the Java world. Apache Shiro and Spring Security are two different frameworks, and they provide functionality in all those pieces that you were talking about. So you can use one of those frameworks to really provide all of the kind of baseline security features and functionality that you want. It's gonna be a one-stop shop for you for the most part.
Because where I'm thinking about, let's use the example of encryption. So yeah, you can encrypt it, but if you're not managing your keys properly, then, right? And so does the framework help you with that?
Yeah, I mean, the framework's going to help you with that. That is one of the most complicated problems in computer science that you just described.
Is it really?
Yeah, key management and secure storage of keys is just a difficult problem for people to deal with. And so,
go back a little bit, Kristen. Let's talk about this. Give us a 101 on it and then kind of where we're at.
So, when you're dealing with cryptography, you're trying to encrypt and decrypt, potentially many different conversations that are going on. And with each of those conversations, you're going to have individual keys that are allowing you to do that encryption and decryption process. And so those keys have to be stored someplace, but that's really, really, really important that they're stored securely. Because if I can get a copy of your key, doesn't matter. I can decrypt. I've got the magic decoder ring, right, that allows me to take your traffic. If I can get a copy of your traffic, I can run it through the right algorithms to turn it back around and see it in an unencrypted fashion. So it's encryption is a really difficult problem, and it's a place where you can get a lot of benefit from frameworks. Another thing I'll say about cryptography: don't write your own algorithm. Right. This is like it's the don't roll your own kind of principle here of algorithms like AES that were created through NIST and through all the different standards they work with and all the different reviewers. It has to be a public algorithm that people have had a chance to pick apart. And so don't ever, if somebody ever says, oh, well, hey, we're going to write our own crypto, I cringe and say, no, stop. Find a framework, find, OpenSSL. If you're programming in the Linux kind of world doing C, OpenSSL is your friend there. They've got tried and true, different routines and things and even some key management rolled in there. But the key here is to get the right tools and don't try to create your own crypto.
And make sure it's not based on some secret, right? It has to be public. It has to have been
it can't
pounded on by everybody.
Yeah, I mean, you can't. If your algorithm relies upon secrecy, then you're already finished. You've already lost because
you've lost before you.
The bad guys, they'll find your info. Well, we'll keep it secret. We won't tell anybody what the algorithm is. Well, you have to write a module, code that'll decrypt whatever you're sending. So the knowledge is out there.
Yeah, it's out there. All right, so we started with requirements. We went into the design. Finally, we got to programming. What's next?
So let's before we leave develop, let's talk about one other really important thing for people to understand, and that is that there is a whole universe of tools that are available for what we call static analysis, code scanning.
What does that mean?
And what that means is after you finish your code, you have a tool, and this tool is really good at looking at your code and looking for known vulnerabilities in the actual code itself. And so what that tool will do is it'll dump you out a list of potential problems that exist in your code, and then you can go through and try and fix those problems before you allow that code to kind of move into the next phase.
Nice. Now, are these commercial products? Or are they just available on the web for free? Or give us some examples.
Yeah, I mean, primarily they're commercial products. There's one very nice company called Checkmarks, which is a relative newcomer to the static analysis space. But there's HP Fortify is another tool that's out there. There's a lot of different commercial tools that are available. And so I think that it's important for, if somebody's out there and they're building an IoT product right now and they're thinking, how am I going to do static analysis? They should look at a couple of different options, and because some of those tools work better with Java, some work better with C. There's another tool called CodeDX that brings a whole bunch of these scanning tools together, which is a nice way to approach it.
Nice.
Because then they give you a single console, and you can get feedback from some of the open source scanning tools, and from some of the other tools that are available.
Now, what do these cost approximately?
These are enterprise tools, so they're not. Okay. It's not $100 a person or anything like that. Unfortunately, but the return that they provide is it's certainly worth the investment there, because you really don't want that code to move its way down. You don't want it to continue down the path into the following phases if it still has major vulnerabilities.
Yeah, no, I can see the value, and it actually reminds me when I was a programmer many years ago, we had a similar tool, but what it did is it scanned for open source code. And so it just gave us an idea of what our potential, liabilities were for reusing code. This makes total sense. It's got to be relatively straightforward to use, and it's like the 80-20 rule. It probably will knock out a very large percentage of mistakes that you had, right? It's a machine. You just run it through.
And they're known, they're not perfect by any stretch. They're known for their false positives. That's the reason people, it's a love-hate relationship, right? You love it when it finds good problems, and you hate it because it gives you too many false positives. So you do have to go through a tuning process.
Yeah, there's a human involved though, right? You just go through it.
Yeah, but sometimes it can overwhelm the human with, if you get 10,000 items, it's really hard. And a lot of times, I've seen that happen before, right? Where a developer will look at it and go,
now you're scaring everybody.
It's too much. Yeah. So the lesson to have there is you have to spend some time tuning the static analysis tools,
the parameters
for your world, right? Don't just run it out of the box, because each of these tools has they give you the ability to customize the rules, and there may be some things that you're doing that it thinks are a problem, and after you look at it, you're like, no, it's not. So then you can tune the policy a little bit. And I wanted to come back to one other thing, because you just hit on a big one, and we haven't talked about it yet, and that's the open source / third-party software.
Okay. So
this is a big problem from a product security and application security perspective for anybody that's building something, but especially in the world of IoT, where you're going out and you're grabbing different libraries, open source libraries and different frameworks, you're throwing them all together. You have to have a process to ensure that when vulnerabilities are disclosed in that third-party / open source software, you have to have an update mechanism into your product. And this is an issue that big companies and small companies are dealing with this now, but it's such a crucial issue, because if you let an old version of open source software, an old library, sit in your product, and you continue to ship it, you may have a vulnerability under the hood that you're not even thinking about.
But isn't an update mechanism pretty much a foundational issue, where it's not just specific to open source, but it'd be pretty much specific to anything that you're using, whether it's open source or closed source, wouldn't it be?
Yeah. I don't see many people using closed source. Most people aren't buying software libraries anymore like they used to back in the 80s and 90s. So,
you dated me. Okay.
Yeah. Sorry.
No, but okay. But when I say closed source, it could also mean the code that you wrote. Now you're going to need some mechanism to be able to update, even if it's just a glue. There could be vulnerabilities that could happen, or it could be that you just want to update your product, add new features, right?
Yeah.
So there needs to be some sort of over the air or whatever, some sort of update mechanism. And what you're talking about is making sure it's in there specifically, though, for open source. But this is going to be more of a general, isn't this going to be, and I know there's even threats involved, there's security issues involved with your update mechanism, but this is something that you should be pretty much building in right from the requirements in the design phase, isn't it?
Oh yeah, So the overall update issue is a superset of the third-party software issue I just talked about. It manifests itself because a lot of times people forget about the third-party software. They just assume that there's no problems in it. So that's why I draw attention to it. But if your product does not have an update feature, a secure update feature, then you're in.
It's table stakes.
Yeah. But you know what? I've heard in the last month or two in conversations with people about products that were deployed in the IoT space that had no ability to be updated. And that just baffles me as a security person, because I know that there's already vulnerabilities in that thing. And they just, when they shipped it.
There were vulnerabilities when it shipped.
Yeah,
exactly.
And now they have no way to reach back out because it was a time to market thing. They wanted to get, we mentioned no names to protect the people, innocent or guilty or whatever. But, it's too bad that that's the approach they've taken, because those products, the people that are buying those products are basically, they have no way to have a secure solution into the future.
Yeah. Now, do you think this is naivety, or do you think it's actually an explicit decision?
I think it's feature velocity. I think it's some of both. That's it's a great way to answer a two-part question like that. Yeah, yes and yes. There's some of it's going to was feature velocity driven, meaning, hey, I want to get this product out there. Right. I got to be first to market. I don't care if I make a bunch of people angry because they figure out in the end. But I think some of it is people are just, especially in the IoT space, there's a lot of companies that are writing software that, this is their first or second year of writing code, as a company. They don't have a 10-year, 20-year track record. So
that's a good point.
Just don't know, And so I think there's some that they're naive, but I think it's also sometimes is just a choice to get to market.
Yeah, and it could be a combination of both, because I think it's right by shining a light on the open source issue, because you may just take that for granted, but that is putting a finer point on it that, it has to include that as well.
Yeah, it may, from a third party software, it may not be our code, but it is our problem, is what I've heard people say.
Yeah, no, it definitely is. All right, so we've developed it. Are we finished with developing it
yet?
We're
done, yeah.
All right, so let's move on. What's next after that?
So after that, we go into our testing phase.
All right.
And when we think about testing, this is the point where we're going to be doing some functional testing that's based on security requirements and just all the requirements in general that the product has put forth. But we're also going to spend some time doing what we call vulnerability scanning. And
what is that?
The idea with vulnerability scanning is we have a tool, and this tool knows about, from a network perspective, application perspective, it knows about lots of different types of vulnerabilities. And what we can do is we can point that vulnerability scanner based on an IP address at our product and say go, and it'll just constantly hit that product with a barrage of different simulated attacks, and it'll record, as best it can whether it thinks it was a successful attack that occurred on the product, and it'll log, and at the end of that process we get a nice report that says, here's all the issues that the scanner uncovered, and then you can go back and examine the product and try to figure out, is there a service that we didn't want to have running in production that's still running? A lot of times that can be pinpointed. It can also pinpoint vulnerable versions of, all the different server components that you have running.
Mm-hmm. Now, is this take the form of a testing equipment, or is it a service, or how do people get at it, and what does it normally cost?
So it can take all of those different. It can be a little bit of all of that, right? So there are some vendors that provide security appliances. They tend to provide some performance as well as some security related testing for you. Majority of these products are software based or cloud based these days. Yeah. So so you can now a lot of people still like to use the desktop based. People in the security world sometimes like to keep their potential flaws closer than letting them go out,
putting them out there.
Yeah. So it's we're talking for an enterprise license. If you had, and a lot of these folks do this by a seat, basis. So you're talking a few $1,000s, for to have a couple of testers able to use these tools at the same time on the product. And not everybody needs a license. This isn't something that you can have an enterprise.
Specialized.
Yeah, and it's good if your engineers and your developers also have some knowledge of these tools and what the results are, because a lot of times when we find something with the vulnerability scanner, if it's code related, we got to go back to the developers anyway. So if they have that foundation, it just helps them a little bit.
So we've talked about two important tools / services. We've talked about the vulnerability scanning. We've talked about the code analysis scanning. Are there any others that we've missed up to this point?
No, those are
that we should be thinking about.
No, I mean, those are the primary places where where tools kind of fit into this equation. It's just there's really not any other tools to recommend at this point.
All right.
And then,
okay, so we've been doing some scanning, and what else we do?
So in the testing phase too, penetration testing is something that
all right, back to pen testing.
Yeah.
Okay.
So, pen testing should not be the first thing that you're doing in this phase. You want to knock out if there's any easy things. That's what the vulnerability scanner's for. It finds the easy problems and allows you to fix them. And then the pen testing phase is something that, you kind of go after when you feel like, the release, the product, whatever we're doing, it's pretty solid right now. And, I think we can go ahead and give it a try. A lot of people will use, some companies like to do penetration testing, have some people on their team that are skilled in that enjoy that, and they do that themselves. Probably most people that I'm thinking of in the IoT space are not going to have that level of knowledge. So there's going to be outside consultants that really specialize in, different testing methodologies that can come in and really provide them with a good return on that investment.
Yeah, and there's a couple givens in my world, and one given is use an IoT platform. Don't develop, the plumbing yourself. And another given is, hire one of these, these security companies to do penetration tests, and white hat, black hat, whatever the case may be, gray hat, because just like you said, the ROI on it is just phenomenal. And two, what you said also, is you're not necessarily going to have those skill sets within, in-house. So this is super important. And since we've done our design, we know where to go, right? We're going to if we're doing the white hat version, we know that we know exactly where to look and to make it pretty efficient too. Is that kind of your thinking?
Yeah. So all of if you follow this methodology of the Security Development Lifecycle, by the time you get to the pen testing portion, you have a number of things that you can share with the pen testers to really, so they can dial in. Pen testers love to look at threat models that have been done. Because one of the things that pen testers do is create threat models, right? Exactly. People think they just sit at keyboards and type in commands all day long. No, penetration testing, a lot of it is thinking, right? It's
at the beginning, for sure.
It's what's the easiest place I can attack this giant system that I'm looking at in front of me? Because we're going to take the easiest way in.
Yeah, and they will hopefully, or maybe not hopefully, find some different threat models that you didn't come up with, but at least it gets them there. And again, if we're just talking the efficiency of dollars and resources, if you have them, they're going to love it, you're going to love it, and it's all good. So that's back in the design phase.
Yep.
Okay, so we're scanning for vulnerabilities, we're testing for penetratability. Are we doing anything else in the testing phase?
No, I think we're ready to release this thing. It's time.
All right, let's release it.
It's time to get it out to the world.
Finally.
Yeah,
all right.
It's about time. We should have a party or something now that we've reached the release.
A release party. Yeah, let's do that. All right. So what do we do in that release party then?
So from a security development lifecycle perspective, what we care about is, first of all, we need response procedures. Okay, we need to, when we release the thing out there, we need to have a way for people to tell us if there's security problems that they've identified.
Oh, what do you mean people? Who?
So could be external security researchers. There's a whole world of security researchers that all they do is they buy versions of products and they run all kinds of testing scenarios against them in their own lab environments. And then they'll contact you as a vendor and say, hey, I found this security problem. Right. We have what's called responsible disclosure, and those are the good guys. Those are the white hats that you were mentioning earlier. That means when you practice responsible disclosure, it means that if I find a vulnerability in the product, Bruce, that you make, I'm going to reach out to you quietly. Right, and you're not going to find out about it on a blog post I wrote, or or some public. It's not going to be on Twitter. I'm going to work with you behind the scenes to say I found this problem, give you a chance to verify that it is in fact a true problem, and then I'm going to work with you so that when I get ready to release to the world the knowledge about this problem, you're going to have a patch already ready to go. So in tandem, we're gonna release to the world, and that way your customer, it's your product, is never exposed with some amount of time where there's an open vulnerability that there's no patch weren't able to provide a patch for.
So what is this procedure then? What does this response procedure look like?
So from a response, this is something that's actually going to be done by an actual team. We have a kind of a supporting piece of that we mentioned in the world of SDL, the Product Security Incident Response Team. And this is the group of individuals that, in a small company, it may be one person, a shared bit of their, what they're responsible for. But they're going to be responsible for, receiving that information, triaging it, and then coordinating with the development teams, and then ultimately, finishing off with getting a fix out there.
Okay, so it's nothing too elaborate. It's just one recognizing that you need this and just tapping someone on the shoulder to have someone be responsible for it at the highest level.
Yeah, exactly.
Yeah. Okay. And all right. So we've got the code out there. We've released it. Some hackers, good hackers, hopefully, have found some vulnerabilities. We know how to handle it. What happens if something goes pretty wrong and along the lines of Target or Addison Madley? Then what do we do? Is this part of this whole scenario?
Yeah, so that's something that's going to be triaged, at least initially. If you have a major breach or a major problem that comes out of this process, this is something that's going to be handled by at least initially by your product security incident response team. Very quickly, That's going to escalate to a Tiger team that's set up to deal with that. And, executive management's going to be heavily involved because there's a communication side, there's a technical side, there's a reputational side of that problem that quickly eclipses and is above the PCERT team itself.
The pay grade, yeah. And from what I've seen, then we've got a response document, right? We've got the phone numbers of people we need to contact. We know who's going to be handling the press. Maybe if you can elaborate on that a little bit.
Yeah, certainly. You definitely want to have an incident response handbook because, when something goes terribly wrong is not the time to try to figure out what the process is. I used to do incident response as a consultant, and those are always the worst places to enter the room where, there was no procedure or process written down. So it's crucial to have that process procedure written down, test it, not during the incident, right? We want to test it at a different time where we can, you can
like a fire drill.
Yeah, people do tabletop exercises with these things, right? You get people from a couple different departments in your organization. Everybody sits around the table and we say, okay, boom, it's 6:00 on Friday, and this just happened.
Flashing the lights,
And then they open the document that's in a binder. They're flipping through. They're like, okay, now what do we do? And they're going through and confirming. And it's so important to when a bad event actually happens, you don't want to have to be thinking about it. You want to be able to say, here's the plan we all agreed to. Let's just execute on it now.
Standard operating procedure.
Yep.
Yeah. Okay. And what else is in? Is there anything else to consider then once we've released it to the big open world?
So we talked already earlier about the update process. So it is so crucial to have that as a feature. Where the
part of that cycle you were talking about,
yeah. Make sure you've got and it has to be a secure update also.
That's right.
Make sure that you're using, you're signing those pieces of software. You're using a cryptographic signature that gets attached to each piece of code that goes out to the field. Because what that does is that prevents a bad guy from sending a version of code that looks like it belongs for your device and potentially getting that bad update to be loaded on a piece of gear that one of your customers has. So that's why secure update and blending cryptography and digital, what we call digital image signing or signatures, is so crucial to making sure that feature is in good shape.
Yeah, so the integrity of the data is maintained.
Yep.
Yeah. Okay. Well, then, from a procedural point of view, or I guess from a process point of view, that's awesome. I mean, I think that just sort of took us step by step through each step, covered it. Is there anything else we missed? Is there anything that we missed in this process?
So just one thing a couple things that are kind of, on the side of this secure development lifecycle process. Mm-hmm. The first thing is you really have to have an education component. So when you have all of these different things that you want developers and testers and release people to do, you have to have some way to actually instruct them about these things. And that usually starts with a foundational set of security lessons and principles, and then you can give them some specific things on top. And then one of the other things that I've seen that's been very successful in the organizations that I've been a part of is you want to create a security community that exists.
Mm-hmm.
You want people to feel like we're all part of the security problem. We're all part of the security solution. But security it's all of our job. That's one of the things I always dislike when I go to work with a new organization. They're like, oh, well, that's the security person over there. You just go talk to them.
Right.
Don't talk to any of us.
Right.
No, if we're doing this right, we're all security people in this room.
So from a cultural point of view,
yeah.
No, I used to say the same thing about sales. I mean, everyone's job is sales as well. Now, I want to circle back on the education. What about the stupid human tricks? So, obviously, a lot of security breaches are by human factors, right? Phishing, people are clicking on the wrong things. Where does that fit in? Is this part of the education, or is it something separate?
I see that as a piece that is, that's something that you have to have, regardless of how big your company is. You have to have that a way to share those basic lessons. When I think of the education piece within the secure development lifecycle, I'm thinking specifically about the secure coding principles. How do you do threat modeling? How do you approach requirements? But what you speak of, I refer to as general security awareness, and that once again is table stakes. Everybody needs in their company to have the knowledge to say, don't click on that link. Don't let people follow you in the door. Trust no one. Unfortunately, that's the way we have to. That's the way we have to play it these days.
No, and if you look at the highest or the most sophisticated breaches, they're often this is how they start, right? Because if you pour a lot of money into it, I think someone has said this before on the podcast, and you've said it as well. Is security is a budget issue. I mean, you can put. I mean, there's gonna be diminishing returns as you reach the limit, obviously. But you can put a lot of money, but you can't if you have a stupid human. Just look at Stepnex. If you have a human that's going to be doing something outside of human procedures, then it doesn't matter how much money you put into this wall. So I just always like to bring that up and reinforce that, because no matter how strong the technical security is, you need to have this human security component.
Yeah, definitely. And I have one more thing on the life cycle, just for because different companies build products using different methodologies. Very few people use the waterfall. And this is kind of laid out from a waterfall perspective of we're going to start, and then in 12 months we're going to ship a product and it's going to go out to our customers. Agile is about iterations and doing things at a quicker pace, and shipping as fast as you can. And then you get into the world of continuous integration, continuous deployment, where you're shipping 50 times a day. The point is that the activities that exist here are still relevant to all of those methodologies. It just comes down to how do you plug them in. So if you're in a continuous deployment world, none of the things that I just spoke of, or very few, are going to be a manual event. Static analysis has got to happen in an automated fashion. Vulnerability scanning has to be an automated run, and then if it doesn't find any problems, it moves the code into production. So I just want people. I don't want anybody to sit here and listen and think, well, that's great if you're in the waterfall ancient approach to doing building products, but we move faster than that. The point is that all of these principles are good. You just have to tweak them a little bit for your methodology.
Yeah, I mean, I think the period is just different. I mean, it's going to be, maybe the frequency will be higher, but you're talking about that cycle, right? I mean, maybe the frequency of that cycle is a little bit quicker, but I agree this process can be applied to whatever your development process is. And yeah, waterfall isn't it, generally speaking. That's old school. That's me school. But now with the clients I work with, they don't even know what that is practically. Yeah. So no, I think that's a great point. Well, Chris, this has been awesome. Where can people find more about you, your company, what you do? Give us some pointers.
Sure. So if people want to find more about me, you can find us on the Security Journey website, which is www.securityjourney.com. And I'm also a big fan of Twitter, so I'm at Edgeroute, EDGEROUTE is a great place to connect with me. And I'd love to have this. I'd love to continue this conversation with the audience here if people want to just ask questions or keep this thing going.
Edgeroute, where'd that come from?
It's, I guess, my hacker handle from a long time ago. So just don't Google it.
All right, I'll put all this in the show analysis notes. Chris, has been a pleasure. It's been super informative, and I like the way I think this is really helpful, because this is a process, but it actually takes you through each step. And I think it's, we've covered different parts of this in the podcast before, but this has been a great way to tie it all together. So thank you for that.
Thanks for having me.
Okay, that was a good talk with Chris Romeo. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Blockchain and IoT and the Advent of Truthful Data with Jessica Groupman. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a processed one.
You have been listening to the IoT Inc. Business Show.